Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Prynawn da pawb, rydw I John Worley, Prif Weithredar Forum Airfield Cymru. Croeso, welcome. I'm John Worley. I'm Chief Executive of the Aerospace Wales Forum. I'm also co-chair of the Space Wales Leadership Group. This afternoon we've got a fantastic session on the smart space platform. I'm joined by Josh Weston of Spaceforge, who's going to talk about in-space manufacturing, Steve Keyworth of Environment Systems, who's going to talk about how we use space-derived data to help aid decision-making here on Earth, and then Tony Henderson of Anwen, who's going to tell us how communications enabled by space are going to enable the provision of health and social care and support services in a rural environment, which otherwise would be challenged by very difficult communications. So sit back, enjoy the show, and please keep your questions coming in, and we'll attempt to answer those at the end of the session. So the theme is Wales, a sustainable space nation. I ought to explain all those logos first of all. I run an organisation called Aerospace Wales, which has been around for 20 years, focuses on aerospace, but it's also covered space. But recently, with funding from the UK Space Agency, we formed a group called Space Wales. And this really looks at both the upstream side of space, which is all to do with the rockets and the satellites and the hardware, but also the downstream, which is the application of space-derived data in helping us to manage the Earth's resources, provide communications, navigation, and so on and so forth. And our partner in all of this, the symbol at the bottom right there, is Welsh Government. We work very closely with Welsh Government, who have been enormously helpful in getting this project moving. So next slide, please. So before we get into the sort of space strategy, the top level stuff, I'd like to talk about some of the underpinning technology that already exists in Wales to support what we're doing. I'm going to start off with our tour of Wales up in the north with the optoelectronic cluster. You will know that Photonics Connectic has just been established, bringing some of these groups around Wales that focus on optoelectronics, photonics, and indeed optics, because the centre at Glyndŵr Optic in North Wales at St Asaph not only gets involved in optoelectronics, but it also focuses on the manufacture of very big pieces of optical kit, which are used as mirrors in satellites, for example. So a huge capability. Next slide, please. And this just focuses in on some of the mechanical engineering capabilities that the optic facility has there up in North Wales. Within that cluster, there's a company called Key Optic. Two bits. There's the bit that makes things like night vision goggles and head-up displays, etc. But there's also Key Optic Space, and they make virtually all of the free world's space glass for reflectors and space covers in space. So if you were to find a satellite there up in space, it would have a piece of glass in it which is made in Wales, which is fantastic. Next slide, please. And I always say we're not part of Fortress Wales. Wales is not an island within itself. It's part of the United Kingdom, and it's part indeed of a global ecosystem. So the photonics capability in Wales links in with over 30 universities spread across the UK. So a fantastic network of capability. Next slide, please. And whilst we're talking about capability, over the last few years, the UK has been building up a whole network of specialist catapults. These are facilities which provide the link between universities and industry and application at the coalface. And in Wales now, we are very privileged to have the compound Semiconductors catapult. Next slide, please. This is based in Newport. Growing around the catapult is now a cluster of compound semiconductor companies, including the well-known IQE. And if you have a phone or indeed any other piece of electronic equipment, the chances are it's got a chip in it that's been made in Wales. Next slide, please. This shows just some of the companies that are involved in that cluster. So there's the catapult itself. There's the Newport wafer fab, one of a few such facilities around the world. And IQE, of course, I've mentioned, plus a number of universities also feed into this very important cluster. Next slide, please. So, also within this, I mentioned the foundry. This has been delivered through a private public sector partnership. Over £300 million has been invested in the compound semiconductor cluster. £38 million of public money has gone into establishing the largest global such facility in Newport. Next slide, please. And compound semiconductors are everywhere. I've already mentioned you'll find them in your phone, you'll find them in automotive, communications, healthcare, aerospace, energy, robotics. Indeed, it's the basic foundation on which much of our technology is based. Next slide, please. But specifically in space, where you would find compound semiconductor chips, you'd find them for thermal imaging, power control systems, energy generation, connectivity, cybersecurity, data security, indeed, everywhere within that overall space system. Next slide, please. And the whole cluster is being developed. Elements are already in place, but there's an opportunity for other organizations to join this cluster. So plenty of room for growth. Next slide, please. And we also have Europe's largest data center here in South Wales, Next Generation Data. And I think this is one of the key opportunities for Wales. I talked about space data early on. At the moment, we've got about 2,000 satellites orbiting the Earth. This is going to increase to 50,000, maybe even 100,000 by the end of the decade. And the amount of data that is going to come down to the Earth that is usable for downstream applications is just going to blossom. But we need ways of harnessing this data and processing it. And we're going to hear from Steve Keyworth later on from Environment Systems. And he'll tell us a little bit about how he's already working on existing data sources to aid decision-making here on Earth. Next slide, please. Move on. We've already talked about that. Next slide. And I think it should also be stated the commitment to research in Wales is very, very significant. These are just some of the amounts of money that have gone in to the facilities I've talked about. So £75 million into Cardiff University's Institute for Compound Semiconductors, for example. So very impressive amounts of investment. Next slide. And whilst we're talking about data, everybody talks about cyber. And this is as important in space as it is anywhere else on Earth. Clearly, with all of that data flowing from space, data in the satellite systems themselves, cyber is going to become increasingly important. The good news is here in South Wales, we have a fantastic cyber security cluster with people like Airbus and Thales very much at the heart, supplemented by a whole army of smaller companies. Next slide, please. I mentioned Airbus. Airbus, we tend to think of in terms of commercial aircraft, but of course they have a fantastic defence and space operation at Newport here in South Wales. and one of their strongest focuses is on cybersecurity. So you may know that the UK MOD is about to launch Skynet 6. One of the key challenges is the cybersecurity of that satellite communication system. A lot of the work on that will be done by Airbus in its Newport facility. Next slide, please. And of course, we're in good company. This is just a sample of the companies that we have in Wales. I've mentioned Thales, I've mentioned Airbus. We also have Raytheon up in the north, who are also very much involved in cybersecurity. And IQE, I've mentioned Key Optic, GE Aviation. On the automotive side, Aston Martin, and high-tech companies like Renishaw. So a real concentration of advanced engineering capability in Wales, much of which is going to rely increasingly on data coming from space. Next slide, please. So now I'm going to turn to the work that we did with the UK Space Agency. So how did Space Wales come about? Towards the end of last year, the UK Space Agency announced the award of grants to various clusters around the UK, and they're all shown here on this map, to really evaluate their own clusters. So here in Wales, for example, we looked at the Wales ecosystem in terms of space. We looked at the ecosystem to identify what the opportunities are going to be, and then we've developed a strategy to say how we're going to get from A to B. All of this is in the public domain. It's on a website, spacewales.co.uk. I would encourage you to go and have a look and then talk to us. Tell us what you think. Give us your ideas, because we're very much a believer in open innovation. This is a case where by working together, we're stronger than working individually. And last but by no means least, we've established a Space Wales leadership group drawn from academia, from government, and from industry to drive us forward and make sure that we deliver on this strategy. But again, I stress, we're not an island. We're working with all of these hubs. And later on in the summer, we'll see the publication of a UK space strategy. So all of this will start to mesh together into a cohesive national and regional plan across the UK. Next slide, please. I mentioned we already base our engineering expertise on very solid foundations. Within aerospace, for example, although Wales only has about 5% of the UK's population, it's got something like 10% of the aerospace population. Now in space, we don't come anywhere near that yet, but our aspiration is to grow to a similar capability with the potential of having a turnover of £2 billion in the space sector in Wales by 2030. That's our ambition. If we can beat it, that's fantastic. Next slide, please. We really started on this journey probably a lot longer than 2015, but the first significant point was when we published our first space strategy at the UK Space Conference in 2015 at Liverpool. And then if we look down the right-hand side, we had a relatively small number of companies that were involved in the space sector. But in the recent exercise, we've done a mapping exercise, and we've come up with something like 60 or 70 companies already that are involved in the space sector in Wales. And that's going to grow, I think, significantly over the next few years. We also talked about an arc of innovation, which involves the universities and a lot of the test and evaluation facilities, many of which have a long history of development, but now form the foundation for the development of the space economy here in Wales. Next slide, please. One of the things that was identified very early on was the need to establish a UK launch capability. So back in the 1970s, the UK was one of the few nations in the world that had its own independent launch capability, and it abandoned it. We're the only nation in the world that has developed a launch capability and then abandoned it. But now it's recognized that we need to recreate that. So there's a whole network of potential spaceports have been identified around the UK. And in fact, in Wales, we have more than one, and I'll come on to that later. But the land-based one is Spaceport Snowdonia. Next slide, please. This is based around, again, part of that technological test and evaluation ecosystem that has grown up for many decades. So back in the 1940s, the Ministry of Defence established this test range off the west coast of Wales. It's 7,500 square kilometres of segregated airspace over the sea, and 1,500 square kilometres over a land corridor running towards Sennybridge in lower mid Wales. This was an MOD facility and still is, but in 2003 it was open to civilian use, and the early phase has been very much about uncrewed manned systems, remotely piloted vehicles, operating out of Aberporth and Flambetta airfields. So those are the two airfields shown connected to the system. But we recognise that Flambetta had also potential to become a horizontal spaceport, that is, not vertical rockets, but rocket systems carried by aircraft or other means into space and then launched subsequently over the ocean. Next slide, please. The airfield itself is an old World War II airfield. It's in a beautiful location. It's pretty sparse in terms of its resources. It was part of the Royal Aircraft Establishment before it closed in about 2004. The airfield has since been reopened and has gradually seen the reintroduction of the development of future flight capabilities. So we've seen lots of UAVs and also some crewed eVTOL aircraft, for example, flying out of Flambetta. But the next step in the journey, the aspiration is to build a spaceport, and the whole red area there at the north end of the diagram would potentially also include a spaceflight academy, a centre for training astronauts and giving people space experience. Very exciting plans for the future, but we hope we'll start to see these come to realisation in the next couple of years or so. Next slide, please. Showing it in more detail. I'm not going to go through that. Next slide, please. And these are, sorry, stick with that one. These are our aspirations for it to become a spaceport. But in fact, we already have at least one client, which is operating out of Flambetta, a small startup company, B2 Space, based in Newport. It was just 2 people a year ago. It's up to about 15 people now, and they're about to launch their first funding round for about £10 million. But they've come up with a concept called the Raccoon, which is a rocket launch system based on a stratospheric balloon. So the balloon goes up to the stratosphere, the edge of the atmosphere, into an area which we call near space. Now, they're planning to launch the first rocket later on this year, sometime within the next 12 months. But they're already using the stratospheric balloons to carry out near space experimentation. So they can take payloads up on the balloon and expose them to the kind of conditions they would experience in space. So it allows some early development work to carry on pieces of kit before they're actually deployed into space itself. So arguably, Spaceport Snowdonia has already arrived. Next slide, please. I mentioned the fantastic test and evaluation system that we have in Wales. So as well as having that whole area of segregated airspace, which is the base for uncrewed air vehicles and horizontal spacecraft, stratospheric balloons, we also have a whole host of other facilities, some of which are in government ownership but open to civilian use, and some of which are in private ownership. Again, I'm not going to go through all of those in great detail, but we've got a fantastic asset base of such facilities in Wales, which we need to use more of. Next question, please. All of this is backed up by some very strong academic capability in Wales. And about the same time that we launched our space strategy back in 2015, a group of 6 universities got together to form the WASP, Wales Academic Space Partnership. And through this group, they now start to collaborate on space-related research, share ideas, and importantly, are able to market themselves as a much bigger network than just a single university. So again, a fantastic step forward. They're very closely linked in, of course, to industry through the Space Wales Leadership Group. Next slide, please. So what's happened since 2015? A lot, lots of new entrants. Spaceforge, that's an artist's impression of their in-space manufacturing capability, a factory in space. I'm not going to say any more because Josh Weston, the larger-than-life co-founder of the company, is with us today, and he'll tell you more about that in the next session. Small Sparks Space Systems, a startup in Cardiff, which are developing their own small rocket launch systems. Black Arrow Space Technologies. And this is fascinating because they're working with a whole group of companies such as Recurve Space, the Celtic Space Council, which is a network of companies spread across Wales, the Isle of Man, and the whole of Ireland, looking at developing a sea launch capability. So if we look at the photograph at the bottom there, you'll see that there's a rocket being launched from a ship. So there are issues around all UK spaceports because we're in a very built-up landmass. When you fire rockets, you've got to try and make sure they don't fly over in inhabited areas. So another alternative is to go to sea. So the team at Black Arrow, the team at Catapults Space Centre are working on developing space launch capability out at sea. So yeah, we don't just have one potential spaceport, we have two. I've mentioned Spaceflight Academy, some really exciting proposals there to develop astronaut training at Flambetta, B2 Space. I've mentioned the compound semiconductors, Catapult. I should mention the ESA regional ambassadors down at the bottom. We've got two regional ambassadors for Wales. One covers Northwest England, North Wales. The other covers Southwest England and South Wales. They are Alan Cross and Andy Williams. And they regularly visit Wales to work with companies who don't even know they're in the space sector or who could be in the space sector. So again, you'll be seeing more and hearing more from them over the next few months. Next slide, please. The other exciting thing that's happening in Wales is technology is just exploding right across the piece. So massive developments in energy. We've seen the offshore wind farms. We've seen potential new developments in nuclear. Hydrogen. So one of the most exciting fuel prospects for the future is hydrogen. And hydrogen can be produced by excess electricity. So when you've got more electricity than you need, you can actually produce hydrogen, which can then be used to power vehicles, to heat your homes, and also potentially to power aircraft. Airbus are looking at the next generation of aircraft being hydrogen powered. A lot of development to be done, but all of these linked together potentially with the space sector. Life sciences is a very important sector, which again can draw from space data. 5G communications. Wales has some particular challenges with the topography, the layout of the land, which means that broadband 5G communications are very difficult to achieve. And you can supplement that through space-derived data. And Tony Henderson, who's our last speaker on this afternoon, will be saying a little bit about that and one particular application that his company is developing. So very exciting stuff. And Living Wales is a project at Aberystwyth, which is looking at historical, current and potentially future data for managing the environment within Wales. And again, we'll be hearing more from Steve Keyworth about how Earth observation data can be used to manage resources here on Earth. Next slide, please. So the key themes that are emerging in our space strategy, which again, I will remind you, is on spacewales.co.uk. Please do go and have a look. Please give us some feedback. Launch systems and launch capability through Flambetta and through the Catapults Space Centre. Test and evaluation ecosystem. Integration with unmanned air vehicles for rural applications. So we can get data from land-based systems, airborne systems and spaceborne systems, and we can combine those. Wales is a particularly strong sandpit, both for technological development because of its topography and environment, but also sociological development. We have some real challenges and real opportunities to enhance the lives of communities through the application of space data. Manufacturing in space, I'm not going to steal Josh's thunder. He's going to talk about that in a minute. Earth observation, Steve is going to talk about that. And I think we also talked about the power of data analytics and cyber in Wales, which is going to be a key part of the support system for the future space industry. We're also developing something called the Advanced Technology Research Centre, which is going to be focused up at Sealand in northeast Wales, not far from the Airbus plant, but adjacent to DECA, Defence Electronics and Components Agency. The focus of this is going to be on defence electronics, but also with spin-off into civil. but we're also developing a stream now around space. So it will also be a space research centre as well. So again, another exciting development. And finally, I guess our strapline is Wales, a sustainable space nation. What do we mean by that? Well, I think the downstream, we know that it can help with all the challenges of climate change. Space-derived data can help us better manage the Earth's resources and help us achieve that greener future. The upstream is also a challenge because if we're going to be launching rockets, we have the same issue we have with aircraft, the potential pollution associated with that. So we also want to develop the technology, the fuels that will enable us also to green the upstream side of space. And we're already starting with a number of projects to support that activity. Next slide, please. I've spoken long enough. Again, I remind you, the report is on the website. If you want to get in touch with me, inquiries at spacewales.co.uk. Please feed your questions in through the chat. We'll endeavour either to answer them today or at subsequent sessions afterwards. I'm now going to hand over to Josh Weston. Thank you.
Hello and good afternoon. Great to be here. My name is Josh Weston and I am the CEO and co-founder of Spaceforge. So a little bit about me. Before Spaceforge, which was set up in 2018, I used to work at Thales Alenia Space, a large European satellite manufacturer, across a whole host of things, but primarily in satellite sales and business development. While there, I was also seconded to the UK Space Agency for about 4 years, working on national security, critical infrastructure, all the way through to assisting with the strategy for what eventually became the UK's first national space innovation programme. So Spaceforge, briefly I'll provide an overview, is an in-space manufacturing capability specifically making products in space for use back on Earth. Now, as science fiction, as that might sound to some of you, it's nothing new. So in-space manufacturing has been happening for the past 50 years, largely in a research-like capacity. It started with Skylab, a US endeavor, which saw the growth of semiconductor crystals. That was enhanced in the era of the US space shuttle with a facility known as the Wake Shield. So that's that middle picture. It's essentially a really big dinner plate that was kicked away from the shuttle while on orbit, and essentially all of the activity happens behind that dinner plate, and there they did things like develop new means of semiconductor production, including molecular beam epitaxy, which is a process that we use on the ground today. And then, of course, came the International Space Station. It's now been permanently habited, I think, for 20 years. It has seen the 3D printing of ceramics, composites. We've seen the production of fiber optic cable by a company called Made in Space, which is about 100 times more efficient than fiber optic cable you can make on Earth, and it has been deployed on the ground. We have seen the 3D printing of organs, including corneas for eyes. We have seen the development of new drugs, vaccine discovery, and even more recently, food. But why manufacture in space? If you didn't have the context of human history and our evolution, the way that we manufacture today doesn't make sense. We live on a planet where we have to contend with heavy gravity, we have to contend with a dense atmosphere, and we have a fairly consistent temperature across our whole planet. Now, we have found ways to overcome some of those on Earth. So when it comes to atmosphere, 350, 400 years ago, we invented the vacuum pump. At the time of its invention, we weren't sure what to do with it. Today, we now use it in the production of computer chips to the most efficient way to milk a cow. And with temperature, we have done similar with refrigeration and ovens in allowing us to raise and lower temperatures. But when it comes to gravity, we've not really found a way of beating it without paying for it dearly at the end of that process. But the cost of accessing space has reached such a point that it's now possible to do it viably in a commercial capacity by going to space and manufacturing there. The benefits of manufacturing in space are essentially that you are able to overcome the barriers and obstacles that you face on Earth. So you have microgravity, allowing near weightlessness. That allows you to do things like improve on your crystal structure, your composite mixing, and even your alloy mixing. It actually enables about 1 billion new alloy combinations that currently aren't possible to make on Earth, although we'll caveat not all of them are useful or profitable. You have a complete lack of atmosphere, so you can access the really incredibly pure vacuum of space, and you have access to near zero, to close to near zero, and indeed plus 260 Celsius comfortably from low Earth orbit. Now, all of those things put you in a position to manufacture in a better form than is possible to do so on Earth for almost any industrial process. Now, uniquely in the UK and indeed in Wales with Spaceforge, we are uniquely positioned to capitalize on that opportunity. We're developing launch capabilities, we have operations capability already, ground segment capability, we have satellite manufacturers and operators, and that allows us to build out the entire ecosystem required to manufacture something in space and use it back on Earth. And that also allows us to close the loop for future opportunities, whether or not that's considering things like launching from the UK or even the future of in situ resource utilization, by which I mean anything from establishing bases on the moon to the mining of an asteroid. And with those products that you make in space and use back on Earth, you can directly address the clean growth and net zero ambitions that the UK have. And importantly, is really for us what addresses Wales being a sustainable space nation. And so Spaceforge, as I said, we were co-founded in 2018, myself and my co-founder Andrew, after working at Thales for a number of years. And we founded Spaceforge on the proposition that basically for all of humans' time in space, it's been an incredible place to point out problems exist. But you still need solutions on the ground to go and solve those problems. So with Earth observation, for example, you can use the data and the intelligence and even the imagery to point out that there is deforestation occurring in the Amazon, or there's been an oil spill which needs to be cleared up, but you still need something on the ground to solve those problems. In-space manufacturing is the first opportunity we've had to leverage the space environment to directly solve some of the most pressing issues of our generation. And so we are developing an in-space manufacturing capability to directly address climate change. So as I've said, in-space manufacturing is nothing new. There are huge opportunities for it as a market, but key barriers exist. Primarily at the moment, that comes down to two things. First, that the only platform available to currently manufacture things in space is the International Space Station. But it's 20 odd years old, it leaks oxygen, it leaks air conditioning coolant, it has astronauts on board, it has essentially through its own age created a residual atmosphere which follows it around. It does station keeping on the regular, using its boosters to maintain its altitude, which affects the microgravity environment. Simply, it's not a factory. And that lack of a dedicated platform means that you can be waiting up to 5 years to lodge your manufacturing experiment on the station. And once you've gone through all of the trials and tribulations of leveraging that piece of infrastructure and you want to bring your product back, there's really only one solution, and that's returning with an ablative capsule. That's exactly how the Russian Soyuz works, or even the SpaceX Dragon. And so after all of that, you've come back. It's not soft. Some astronauts describe it as a car crash. And in that microsecond of impact, you can potentially even lose your product in the way that it comes back to Earth. So at Spaceforge, we are developing a reusable space vehicle, which is entirely independent and low cost. By independent, I mean that it sits away from the space station. So we're conventionally launched, a bit like a satellite. It's dedicated to one singular manufacturing process at a time in order to enable scale. And the architecture of that platform is also scalable in its own nature, starting with small multi-kilo satellites, but potentially even moving up into the past the ton capability. And at the end of that manufacturing life cycle, the entire platform is returnable, which means that we can recover the platform, give the payload to the customer, and start the entire process again. And there are a huge number of opportunities associated with in-space manufacturing. So access to the unique qualities of the space environment combined allow us to manufacture new semiconductor crystals, new types of composites and alloys, and even new life science, such as pharmaceuticals and vaccines. And so here is a small case study. This is just us looking at one of the markets which we're interested in, which is composites for telecommunications. And here is the jump in energy consumption from 3G to 4G and the 5G rollout. So I will caveat that the 5G number is based on the same coverage as we currently have in the country with 4G, but as you can see, an enormous jump in your average, in your annual energy consumption, taking it from about 70 million a year on 4G to about 700 million a year on 5G. Now with Spaceforge, there are parts of that telecom infrastructure which you can replace, which can more than halve that energy consumption each year. That then has a knock-on effect of improving your overall system efficiency and dramatically lowers CO2 emissions by about 75%. And that's even after we've made the trip to space to manufacture those products. And I appreciate that that might sound a bit like science fiction, and we are probably a lot further along than you might think. This isn't just a paper study. All of the technologies that we have under development have already progressed to testing. So the image there on the right is from a trial platform, our first mission, and our first type of satellite is called the Forge Star 1. This was a drop test of it in June 2019. And importantly, it did land, and it landed where we expected it to. It was a relatively low altitude drop test, and we went and picked it up in the Forest of Dean. But just under a year ago now, we were 2 people in a garage on the outskirts of Bristol, and we've since exploded with growth. Next week, we are 15 people. We are venture capital backed, including by the Development Bank of Wales. And we've just moved into our first satellite manufacturing facility in Cardiff, making us, I think, the Wales's first company to design and build a satellite with it entirely within Wales. And that is really all I wanted to say, I think. So I'm quite happy to pass it on there and look forward to your questions in the panel. So thank you.
Thank you, Josh. Excellent presentation. So in space manufacturing, now we're going to move on to Steve Keyworth, who's Director of Environment Systems. He's going to go to the downstream end of the spectrum and talk about how space-derived data can assist decision-making on Earth. Steve, over to you.
Good afternoon, and thank you, John, for that introduction and for the invitation to talk in this session on smart space. So today I'm going to talk you through our experiences of using data from satellites to deliver near real-time evidence and insights. Satellites have been around since, Earth observing satellites have been around since the 70s, but they were largely research focused. It's only in the last 5 years has Earth observation from space gone truly operational. We have a virtual guaranteed supply of imagery. We have vast processing capability in cloud computing, and we have the algorithms, including AI, to analyze the data. And most importantly now, we've got the know-how on putting it all together and using it to solve real-world problems. So in my talk today, I'm going to start by introducing environment systems, and then I'll give you examples of a range of agricultural and environmental applications, from bananas in Colombia through to climate change in Wales. So who are environment systems? Well, we're a data business, and we help governments and businesses across the world to better manage our environment and grow more food. We're extremely proud to be an Aberystwyth-based business, and we have been since 2003. We've also got offices in Oxfordshire and Columbia. And if you look in the little map on the right-hand side of the screen, you can get a feel for where we are currently working around the world. To give you a feel for our satellite pedigree, in 2020, Environment Systems delivered over 400 million square kilometers of satellite analytics. For context, that's nearly 3 times the land area of Earth. And using that data, we monitored over 1 million parcels of land globally for governments, businesses, and supply chains. So what do we do? Well, we help protect, support, and promote healthy ecosystems with a particular focus on biodiversity, carbon, and water. We support sustainable and resilient agricultural practices, in particular with near real-time intelligence to support land managers, farmers, and advisors. We increase productivity and manage risk in supply chains, giving the boardroom visibility of the crop, but also the other way round, giving people at the coalface looking at the crop the same type of visibility that you would get from the boardroom. And finally, we deliver in the context of a changing climate. Everything listed above, we look at not only today, but in scenarios out to 2050 and 2080. Satellite data starts off very raw and needs a lot of work doing to it before you can get the value from it. Now, Environment Systems Satellite Data Services is a cloud-based system that automatically pulls in satellite data and applies analytics to the data to turn it into information and into knowledge. Through this system, we access virtually all available Earth observation satellites, but primarily we use the European Space Agency Sentinel satellites. This includes both the traditional optical satellites, so in this case Sentinel-2, and also the more novel synthetic aperture radar or SAR Sentinel-1 satellites. Now, Sentinel-1 is what you're seeing on the screen now on the map on the right. And it allows us to get measurements through cloud, whereas the optical satellites, you need to have a cloud-free situation, which across the UK and many parts of the world is not that common a phenomenon. And what the Sentinel-1, the SAR data does, is it gives us measurements on the structures of the surface of the Earth, whether it's rough or smooth. It tells us about wetness and it tells us about dryness. So you could imagine a forest being rough and a lake being wet and grassland being relatively smooth. In Wales, these satellites take measurements at least every 6 days, and there are other constellations available that take daily images of the Earth. If you were to close your eyes and run your very, very large hands over the surface of the Earth, Sentinel-1 radar would tell you what you feel with your hands rather than what you can see with your eyes. Now, looking at the 4 rolling windows here, you can see how much seasonal and or real change there is throughout the year in the 4 locations here across the UK. We often combine that satellite data with modelling. So the satellite data gives us our observations that help us to design, parameterize, and validate our models. Sense is a good example of this for modelling natural capital and to help us to understand where in our environment is working well. For example, this can include biodiversity, food production, and water storage. It can also help us to understand the best place to site new activities or developments, including new wind farms, timber production, or new housing developments. And it can also help us to understand the issues we need to avoid and how we can use nature to help us to avoid them in the first place. So when making decisions, we want to avoid our decisions introducing new issues or making matters worse in respect of, in this case, erosion, pollution, or flooding. For example, how can we use planting the right trees in the right place to help us reduce the effects of flooding? So the examples I'm about to give will include informing decisions at the field and the regional scales, and it will showcase the use of business intelligence tools to help communicate the information to decision makers. Satellite imagery, whilst is about the imagery, is actually about how you extract data and intelligence from that imagery and serve it up in a way that can help people make real-time decisions. Let's move into the examples. Okay, we're going to start in Peru. In Peru, we monitor the national asparagus crop. Now, depending on how you slice the statistics, Peru is number 1, 2, or 3 in the world for asparagus production. And it's worth annually in exports from Peru about $490 million a year for that crop alone. What we're seeing here is a dashboard view onto the asparagus, identifying each of the individually cultivated plots. And we've done that automatically by applying artificial intelligence algorithms to the satellite imagery. From that, we generate estimates of planting and harvest dates. And these results are updated at least every 2 weeks automatically by the system. The dashboard updates as you can zoom, and you can see the cycling of the image here. It zooms, as you zoom in and out, we can see the total area of the crop, the area in harvest, and a forecast as to how many days to harvest. And you can see those in the little windows on the left. All of these are key indicators for when the crop will be ready to harvest. This in turn helps to plan moving the crop to market. There are often decisions to be made in asparagus, whether to move the crop quickly but expensively by air, or more slowly but more cheaply by sea. But ultimately, you've got to get your crop to the market at the right time for the best price, particularly when you're competing against other production from other countries, for example, in this case, Mexico. Now, this product is being used to monitor the cultivation of asparagus across the whole of Peru. And using the data in the dashboard, we can not only understand the availability of the product throughout the year, these data can also be related to other sources. In this case, we've got the volumes being exported. So you're comparing real-time, near real-time, on-ground analytics with other market intelligence to help you make decisions about moving large areas, large volumes of crop about. Right, now let's move to Paraguay. For non-permanent crops like soya, we offer planting season monitoring. Here we're monitoring the soybean planting for the 2020-2021 season in the state of Alto Paraná in Paraguay. This monitoring, as shown here on the screenshot of this particular dashboard, is segmented by municipalities, offering regional statistics, and it shows the prediction of monthly harvest by municipality. Analyzing the information on the soybean season generates many terabytes of data, which were all processed in the cloud. Now, for this region, there was 20,000 square kilometers being monitored, which, of course, as we all know, is the size of Wales. So we're looking at large scales here. It's worth noting when we're looking at soybean that as a business, Environment Systems operates a staff-owned ethics policy. In this case, it means that we are only happy to work with farms and suppliers that are certified as having in place responsible production systems. It puts us ahead of the curve of upcoming legislation, for example, the Environment Bill in England, that will put the onus on UK businesses to only source commodities from deforestation-free sources around the world. Next stop, Colombia. In the north of Colombia, we're using satellite imagery to monitor the areas under banana production in the departments of La Guajira and Magdalena. Colombian exports of banana are predicted to hit $1 billion this year, so it's very big business. And many of you will know that bananas for eating are from a single variety, known as the Cavendish variety, which is very susceptible to the Fusarium disease. Fusarium is spreading in large areas around the world and resulting in areas of production dying off or being removed altogether. The satellite monitoring of bananas here is presented monthly through an online dashboard. The dashboard reflects the changes in the areas planted from month to month in each municipality. Now, our banana monitoring here provides a strategic monitoring tool that is then supplemented by targeted local drone flights and ground visits for validation and action about removing diseased trees and identifying production volumes. Right, finally, closer to home. We're in Wales here with a little map on the right. So in the UK, there's about 5 million hectares of managed grassland. About 50% of Wales is grassland, and most of that is used to support the livestock industry. Globally, it's estimated that there are about 3.5 billion hectares of pasture. It's also, grassland, one of the least understood and least monitored resources that we have. While many other crops have benefited from precision agriculture or restoration agriculture principles, grassland has been largely missing out. A couple of years ago, we set out to change this thinking and have developed analytics applied to satellite data, and in this case using the radar satellite data that sees through cloud, in order to monitor the pasture and understand how it's performing. What I'm going to do now is show you an animation of a handful of Welsh fields over a 9-month period, where you can see the feed value. That's the feed value to the livestock. That's measured in the kilograms of dry matter, or DM, as you can see at the top, kilograms of dry matter per hectare, and how that changes over time. There are 2 fields in particular on the map on the right-hand side, the orange and the blue one that we'll be looking at. So they're shown on the map on the right, and as the graph builds on the left, you'll see the line extend out, and you'll see the changes in the feed availability across these fields. So you can see the blue field, which is at the lower end on the right-hand side on the map, is the bottom part of the graph, and you can see it's being less productive than Bangronfa field, the orange field. We can take these measurements on a very regular basis. It's available weekly. We tend to summarize it to be every couple of weeks. And you can see how Caeshed, the blue field, is currently performing less well. We're not saying why that is. It could be because of applying fertilizer or not. It could be due to cutting or not. But we're just clearly monitoring which fields at different times are performing. You can see a slight change starting now. The blue field is starting to pick up and the orange field is starting to drop away. Now, why is that important? It's important because farmers don't treat a field as a single entity. They need to move their livestock around. They need to work out if they need to supplementary feed their livestock. So having this subfield intelligence available routinely at a price that is accessible to agriculture means that you've suddenly got this amazing intelligence stream to help support decision making in moving your livestock about. The other value in this is that grassland is a major carbon sink, and in the UK, after peatland, is the largest carbon sink we've got. And in the top 1 metre of soil stores over 1 billion tonnes of carbon. So managing this in a very careful way is important not only for food production, but also for climate change. Which leads me nicely on to my climate change example, and this is my final example. At the beginning, I mentioned the climate context, and given current predictions, this context is now crucial for any agricultural or environmental decision making. Here, we've got a project that was led by the Welsh Government to model how 118 different crops could perform in Wales over the next 60 years. It includes your traditional potatoes and cereals through to the downright novel and exotic, including things like tea and saffron. Now, the satellite data in this example has already contributed to the IPCC climate predictions. So actually, we didn't do any satellite processing of the data ourselves. That already came to us. But when you look at the modeling needed, we use the outputs to enable us to run scenarios to show how the climate context is going to change lives in the coming years. The example we've got on screen here is oats. On the left, you can see the present day extent of land that has high potential, limited potential, and not suitable for growing oats. On the right, you can see the oat biophysical potential for 2080 under the high climate scenario. I draw your attention, for example, to Monmouthshire, which currently has a reasonably high to limited potential for growing oats, down to very little potential in 2080. Oats isn't a dominant crop in Wales, but if you look across the 118 different crops and you look at those different scenarios, we end up in a situation with key policy and commercial data here that allows people to plan not for this financial year or next financial year, but over a lifetime, which is of interest both to governments and citizens and shareholders. So finally, I wanted to give you some key impact headlines on how data from satellites is delivering value. This is just some examples from Environment Systems. Due to some commercial sensitivities, I've anonymized a few of these, but hopefully there's enough to give you a feel. So satellite data has been used to deliver evidence to the recently launched Future Wales National Plan 2040. We routinely increase crop yields from using satellite analytics by 10 to 56%. In one specific example, a 10.3% yield increase led to an increased customer revenue of over $2 million for that one season. We've improved national forecasting for soybean production compared to actual production by over 30%. When you look at the areas involved and what soybean goes into, that's an enormous improvement. And finally, in addition to the commercial successes, which are obviously important and help to drive the business, we're also very proud of how we work with smallholder farmers in places like Latin America and the Caribbean and in parts of Africa as well, to give them a variety of different access to outputs to satellite analytics, not only to the farmers, but to advisors and regional government advisors. And finally, we're also very proud of the fact that we're enabling the next generation through funding PhD students in universities in Wales in things like satellite analytics, crop and natural capital modelling. That's it from me. Thank you very much.
Thank you, Steve. And now we're going to hand over to Tony Henderson from Anwen to complete the list of presenters, and then we'll come back at the end for a panel discussion. Tony, over to you.
Thank you, sir. Can everyone hear me okay? Hello.
Yes, we can. Yes, we can.
Super. Hello, my name's Tony Henderson. I am Chief Executive by default and Chief many other things for Anwen Limited. We're a new company that working in this field. And I'm going to sort of start really by describing the journey, because we've been in existence for less than a year, and it's been a very rapid year. My background is I'm trained as an engineer and worked in the music industry for 10 years before I joined the BBC and moved to a more commercial role in commercializing some of the BBC services 20 odd years ago. And most recently at Microsoft, working in their telecoms thing, helping BT television scale. So I've worked both as a background as an engineer and then in commercial roles ever since. But at the end of the day, I've always enjoyed building things and being an engineer and then understanding the technology. And a year ago, really, we started, two things happened. Firstly, the sort of realization came that voice services were becoming much more available in terms of what you could do, and also the hardware that you need to run them on was becoming very inexpensive, and the use of AI systems was becoming much more prevalent. And with two partners, one in Wales and one in Wokingham, we've been talking on since Microsoft days 7-8 years ago, when Fred and I both worked at Microsoft, and Hugh was at S4C, running the digital program there. We've been looking at sort of projects and things we could work together, and we felt the time was right for the use of voice technology, and potentially also for bilingualism, to work in both English and Welsh. And at the same time, this is at the beginning of lockdown last year, we realized that there was quite a major challenge going on. So if I can, there we go. And this is really the isolation for large swathes of society. And the isolation, some people were able to keep connected with broadband, but others weren't. And it's often the most vulnerable people that found they were digitally isolated. And because of COVID, particularly facing massive periods of isolation. And also the challenge of providing any kind of health or social care was also pretty hard. And I've been through this myself at a level. I had to look after my elderly mother several years ago, so I understood those challenges particularly well. And we felt that if we were going to build something, that we really wanted to build something that helped work in this space. So we looked at really several kind of use cases, but what we came to the conclusion is that exclusion was a business. If we could solve this problem for the most difficult use case, you fundamentally had a chunk of society that were excluded by COVID from healthcare and public services because they were isolated and you could not reach them. And this, if we could solve for the hardest business model, then everything else would be much easier. So that was kind of, it's a bit of an unusual approach, really, exclusion as a business model. But I'll come back to it later. But that's sort of how we really started the process. And we started to envisage what sort of services that we could build with our thinking. And really, we sort of looked at two ends of the scales. And here, these are just some of the use case slides that we developed for building a bilingual system. So there are the areas in rural Wales where Welsh is a first language, and particularly as people get older, they return to their first language as a core piece. And the moment you say to people, you can't use a service because it's not available in Welsh, you're excluding people. So our view was that we had to make it work equally well in Welsh and English. And this was a key part of our approach to how things worked. And this idea really about looking at care type services and trying to understand sort of small interventions, but really critical ones around communications. In terms of sort of helping people just coordinate, even sort of simple things like coordinating travel arrangements are really, really hard for healthcare providers to do today because they all have their own systems. None of them talk to each other. None of them make them work. And this is something potentially that we could potentially do. And it's just helping people coordinate and understanding and connecting them in a way that was really important. And it's whatever should happen, we need to be simple, non-intrusive, coordinated, meet the needs of the people that required it, and to try and sort of be incremental and not try and sort of rule the world. And equally, at the other end of the scale, you've got people who are moving into living on their own, independent living for the first times, and people have struggles with that. And it's having an opportunity to give them a sort of effectively just helping them on that journey, and potentially just giving them a sort of nudge in terms of what they're doing, in terms of their day. And we one of the things we've done extensive research around the use of voice technology as part of the project. And one of the things we found is that one of the key insights we found is that morning night times routines are really critical, and that's when people feel loneliness most often, and that's the opportunity without basically to help people feel included without having to use screens. We looked as part of the research at all the existing technology, and the fundamental problem with all voice technology is it's all built to serve its own masters. And whilst some of these services do serve multiple languages, they're pretty limited in terms of what they can do. They all want you to do the things that their makers basically want to do. It's really quite basic. We have some potential to work more with Microsoft has acquired Nuance, one of the players in the space, which is quite exciting. But fundamentally, we've not made the progress we'd have liked in the voice space, just because of the availability of a Welsh language recognizer. And in our view is that if we're going to do it, we want to do it really well, because there's no point in making, if you're going to build it, you want to build it properly. You want to do something better, fundamentally. So our vision when we set out to do this, and we've received funding from both Innovate and the ESA BIC process to build out this vision, was to basically build a service that it was the core thing about it is that it had to be persistent and reliable. Whatever you do, if the power goes down or the broadband goes down, your service or your friend disappears. That's not much good. It's really hopeless. And those are the two core things that we really thought were absolutely vital. If you're going to provide someone who's going to give digital help, a voice service, it's got to be persistent and reliable. The second thing that just really occurred to us is that if you are going to use that kind of service to bring back things like, just a check-in service or any kind of sort of, communications coordination arrangements, the two bits that are really important are privacy and data sovereignty, and you cannot help any kind of public service environment if you can't solve for those two issues. And, all the off-the-shelf devices at the moment can't even get close to doing that. They're built to serve their masters. They're not built to solve these types of issues. So we basically, we looked at building a chain that would create a wireless network using LPWAN technology that could reach out into rural areas and connect people who didn't have broadband. And we would create a device that, instead of looking like a speaker, would actually look like a household objects. So it wouldn't be intrusive. It wouldn't be, look like a robot or, have to get in the way. It should be something that fits into an environment. And it uses connectivity and put battery support in the device, and the persistent connectivity, so that if anything happened, you knew that basically there's a way of providing some kind of heartbeat in a domestic environment. And as we were sort of starting to explore how to do this, we realized that if you're going to solve for the use case, if you're going to solve for the exclusion case, you've got to be able to connect anywhere. And the only way you can persistently do that is to use satellite. So unlike the sort of our innovation in this space is not particularly around sort of designing new satellites or technology. It's about taking what's there in terms of data services that are available. And our use case is really quite different in many respects to sort of some of the cutting edge stuff. We're looking to find services that are all about economics, and we're looking to find modems and services that you can integrate quite easily. One of the biggest problems with this type of connectivity is DHCP routing, which is all around the dynamic IP addresses in the home. If you have a service that can't manage that, you spend your entire life watching your VPN network go down. You go, well, that's gone again now. And you've got to have a service that fundamentally gives you a really rock solid VPN right the way through to our hub device. So really, that's our challenges around finding satellite services. So we've been testing with Inmarsat. We're about to start testing with Starlink, and we've got a Eutelsat product we're looking at, and we're trying to find services that are easy to integrate. And also, the other big requirement for us is power. Because fundamentally, if you're putting something out on a remote site to power a hub, if it draws a lot of watts, it's not going to be particularly effective. You're going to have to build a massive solar rig around it to make it work, which make the economics not quite work properly. So so that's kind of how we think about it. It's about being able to get the data and just knowing that we can drop it anywhere. And the testing we've had so far is it's been reasonably successful. We think we can create a range of options for doing this. But the beauty of it is that when we talk to people about deploying in other territories, that you can say, right, we can literally build a set of kit, put it in a box and ship it to you, and take it out and drop it on the ground, power it up, and it will work. And that's really quite something. That's really our core raison d'etre. So the team we've drawn together, range of corporate backgrounds. Yes, we'll see BBC, Microsoft, and a lot of engineering expertise in there. And so we start from a standing start last summer. We started building at Christmas this year. And you'll see two of the devices we built there, the hub and the consumer device that we built there. And this is the hub deployment in Wales. So this gives you an idea of the scale. So we built a unit here that you can put pretty much anywhere. We've used 3D printing to create a sort of unique shell that's, if you're gonna put it up at hillside in Wales, it jolly well needs to be waterproof. And weatherproof, and at the same time very simple construction. And on the right hand side of the screen there, you can see the power system, very simple solar power system we've got there that powers both the satellite and the hub, so that we can set this up pretty much anywhere. Rather than sort of build sort of proprietary electronics, we've used off-the-shelf electronics and license fee spectrum to build the network hub. And really, I mean, this is just a shot of the electronics in the space. This is all off the shelf. And when people build out these type of networks, they always think about a network and then they add the computers. And we've built, we have a web server in every single hub and every single device we make. And so we think about it, instead of it being a network with computers, we think about it as a computer with networks. In other words, the user interface is fairly consistent and the networking is taken care of at the back end, which I think is quite different. And this is an idea. This is our first development units as we're putting them up in South Wales. So we've tested the hub technology in 5 locations across the UK, and we've got pretty good at understanding how that works. And it reaches, the reach is really pretty impressive. We can get up to about 10 kilometers off each base station, and you can mesh network them together very effectively. And our design team has got really depth experience in terms of building monitoring control systems. So actually, we don't have to necessarily think about the radio side. As I said, we can think about, how do you connect and how do you see bits of data, and how do you know that it's reliable, and how do you know it's persistent. And which brings me neatly to Wales. And Gwynedd is the area that we think is the hardest to do, pretty much, although in Wales, but primarily because you not only have mountainous area, but you've also got natural Welsh speakers, and you've got an enormous amount of area to cover. So if you imagine 823 square miles. The 20% of the population of 120,000 lives in 823 square miles. That's an enormous amount. If you're a healthcare or social care person, you've got an enormous amount of driving to do just before you get somewhere. And if there's a problem, you're not going to know about it for some time because of the distribution. And the majority of the population is Welsh speaking, so the service has to be absolutely purely bilingual. And also that the connectivity is 3G, 4G, 5G connectivity is limited, and so therefore the space components are going to become increasingly important. But we sort of said, okay, well, if we were going to build out in Gwynedd, what would that look like? And it looks quite a busy diagram, but actually it's quite doable. We could provide persistent coverage over the whole of Gwynedd for a fraction of the cost of doing this with a 3G or 4G unit. And this is using a combination of satellite and 4G, satellite remote areas, to provide that persistent connectivity back. So the final part of the vision I haven't really talked about, as it's still work in progress. So the hub side's finished. We built it and we tested the plant. We know all that bit works. And what we're doing at the moment is we're working on the consumer device to get that up to speed in terms of services. This is just a quick demo. As part of the development side, we built an app that allows you, using an Android phone in this instance, to basically monitor your both your blood glucose and also your blood pressure remotely. It's really quite simple, but if you can plug that app into the network, you can set people up who are diabetics, who've got heart issues, and the app will walk them through the process, so that they can do that on a daily basis or whenever they need to do it. From a healthcare perspective, it means you don't have to have a nurse come all the way out to sit and do that. You can actually train people to do it and walk them through it at home. And then once you walk them through it, the moment it's done with a text-based service, but the goal is to take the app and move it to a voice-based service, is the next step, and then connect the back end of the app so that we can take the data off the app securely all the way across the network. Remember, sovereignty, privacy, and then drop that straight into an off-the-shelf healthcare system. So whichever healthcare provider or service wants to take the data, you can integrate that straight into Microsoft or Enterprise Cloud, whatever you need to do in terms of doing that. So you can very inexpensively, you can make this work over vast distances. So when we started the project a year ago, we set out to build a prototype of a voice-based consumer service and a resilient network to support it. And then very quickly, we realized that we need to add the satellite backhaul component of it. But as we built out the network, we've realized, that's the healthcare mobility language inclusion is a key part of what we're doing. But we've realized that the network technology opens up a huge range of opportunities for gathering data from sensors and a range of sources and delivering that securely across a network. So we've been looking at projects around waterways in terms of doing water quality, flood risk. We've been looking at, we've got a project we put together for the built environment. We believe we can have we don't believe we believe we can solve the monitoring issues that the Grenfell situation has created. We can provide a solution that will do that. At the moment, there is nothing that helps people who live in those blocks of flats monitor what they're doing, and the new building regs put enormous onus on building owners, and we believe we have a solution that can do that. And we're also looking at forestry projects. I was just interested listening to Steve's presentation, so very relevant to what he's doing in terms of actually sort of monitoring activity in forests, not just in terms of sort of the quality of the crop, but also just monitoring general activity along roads for things like illegal logging and those type of activities, and who's coming in, who's coming out, those type of technologies. So we have a range of projects going forward that we're looking to develop using the networking technology. The healthcare and the social remains a key part of it. But in the next few months, we're going to be exploring some parallel projects using the networking technology to connect, and we've repositioned ourselves to carry on our work, but also to work basically in natural environment, which is helping with both, monitoring natural environment, climate change, forests, and then also the built environment I was talking about for fire. Our three core aspects of this are the network piece, the platform that connects at scale in terms of bringing back the data and putting it onto corporate platforms. We've got great experience of doing that. We've worked at Fred and I have got 20 odd years of experience at Microsoft delivering projects, and creating models that can bring new insights in terms of taking those tools and allowing people to pull data securely from their sensors and using it for a wide variety of sources. I was talking to John earlier, and he said, well, how would that impact communities, and why is that important? And at the moment, communities are we call it the barricades of globalism. They're heavily dependent on global organizations to provide basic services. Some are consumption services, others are social services, but these types of services. So, and that's one of the things that we have in mind, is that actually there are a whole range of applications that a network can connect in a community, which is really powerful. So the hinterlands of localism. It's something we can definitely empower, because, our data network's not enormously large, but it's very persistent. It's very reliable, and a WhatsApp text only uses a few bytes of data. So that's the journey we've been on with Anwen, using the space technology, working out how really the economics and the power consumption to allow us to deliver a range of services into communities across Wales. And I talked about exclusions of business model. These are all the things on the left that we believe that we can solve for. And as I said, our three periods: the built environment, healthcare, and public and community services, and the natural environment. We believe we can solve for all those issues on the left. And the way we think about the world, I just put a note of it on the right, is we think about the world in a completely different way, because we think that's the only way forward. You have to look at it as if you can solve for those issues, then anything's possible. And I've added one more slide here, which is Wales as a business model. Why do we end up in Wales? Well, Hugh's a partner. He lives in Bridgend. My brother actually lives in Swansea, and the company's based in Swansea. We felt that Wales is just the most outstanding place to be to develop this business. The bilingual challenge, if we can make the bilingual channel work, we can make bilingualism work anywhere. The terrain, as we've talked about earlier, the topography, and practical solutions. The web server and every single thing we do allows anyone to access it and create and build and set up services. The fact that Wales can operate as independence and it has the ambition to operate and do it at scale makes it a fantastic place to be in business, and we're very proud to call ourselves a Welsh company. So just say thanks, John, very much for the opportunity. Those are our partners there. And thank you very much for the opportunity to speak today.
Let's go on to Mike. I'd like the rest of the team to join me now, if that's possible. Could we get Steve and Josh back? Well, over the last hour or so, it's been a privilege to share the platform with you guys, because what you're doing, what you're proposing to do has just blown my mind away. It is so exciting. It really is. Your piece, Tony, about getting into the communities. There's a Canadian songwriter, singer, musician, Lorena McKennitt, who came up with this idea of wise and healthy communities. So, we talk about smart cities and smart technology, but actually the real challenge is the counterbalance to globalization. How do you get tech back into communities and serving the communities rather than the other way around? And I think you're on the right journey. But you also raised the issue of Wales, because I think Wales is a fantastic place. It's a technology sandpit, and it's a sociological sandpit, and the ideas we develop can then be sold around the world. So I guess the first question I'd put to the panel is, all of you, is why Wales? What's Wales got to offer? Josh, you're on mute. There you are.
That's all right. I was a bit worried about the headset coming across there. So why Wales? Number of reasons really for us. So as I said in my presentation, we started in typical startup fashion in a garage, building prototypes, breaking prototypes, and went out for our quest for our first fundraise. And the Development Bank of Wales was one of the first funders that we approached, and they also said yes. So after that, we stopped needing to look quite as far, and so that encouraged us over the bridge. It was only a half-hour trip, and from then everything else has really compounded that initial decision against the fundraise. So Smart Cymru is incredibly beneficial. Previously underpinned by the EU funding. I'm hoping that there's a continuation of Smart Cymru in the future for the other projects we've got going on. Better access to government, so working with the likes of Elaine Chawles on developing our offering, access to the different industrial clusters, like the one around semiconductors in Newport, for example. And to be honest, so we moved, our HQ is technically Newport, but we moved into a brand new facility in Cardiff in April. It's a great place to be. We're now a team of, next week we're a team of 15, and we will represent 10 different countries. All of us love being there, not least because there are good places to go out for a beer. But there is an incredible energy that I hadn't found in the space industry really until setting up in Wales, and I like it. I feel like there's a little seed in everybody's stomach in Wales that's burning to demonstrate that we can do it too. And for me, I think that comes across in pretty much everything that we've been doing and everything we've had access to by being based here.
Thanks, Josh. I'm going to turn to you next, Steve, because Steve, you're selling your stuff, doing analysis all over the world, and you've said to me you could be anywhere. So why are you in Wales? What's the attraction?
So we originally, my co-founder and I set the company up in Aberystwyth, and so initially we had to attract people to us, but interestingly, that hasn't been the issue more recently, because actually people want to be based in and around Aberystwyth. It's an amazing place to live. We can do anything we do remotely. As I've described to you in the past, John, the Earth observation analytics we do is very non-sticky. So you're not wedded to a factory. You're not wedded to a facility, and actually you can do it pretty much from anywhere with a good internet connection. Therefore, it's a place people want to come, and to me, that's a really good thing, and that's got a lot of longevity in it.
Thank you. And Tony, you've already said some pretty strong things about why you want to be in Wales. What else might you add to that?
I think I'd add probably the sort of one of the most poignant moments I had is when I've been in Wales many times, but when I went to set up at Hughes place, we set up in the valley above Pontycymer, and it's a mining town. It has 5,000 people living in it. And you realize that, it's still a thriving community, but you realize that town was built with an enormous sense of purpose, a century or so ago, to mine coal. And now that sense of purpose has been removed from it. And there's a hunger I can feel just talking to people that, what's next? What do we do next? And I think there's an enormous opportunity in Wales to basically, connect everything, get people trained up in terms of understanding how to, and it doesn't have to be, they don't all have to be computer science. Our whole goal is that someone with a reasonable degree of technical competence can set something up. You don't have to be a computer programmer. I have a problem to solve. Here's what I need out of it. I've got the tools in front of me. I can do it. And to me, just sort of thinking about what you could do in that sort of community was said to me that we'd made the right decision, because there are communities like that all over Wales. And giving people tools that can help them, that can help them say, okay, I can solve problems, I can do this. And once we've solved some of these problems in Wales, we can then take them out to Wales and help other people around the world solve them anywhere on the planet. And with the space connection you're talking about, we really can land anywhere on the planet and set up shop and do things. So I think it's the hunger and the desire and the need and the sense of purpose that really strikes me, going forward.
Thank you. We're rapidly running out of time. I'm going to get the big hook at any time now, I suspect. So really final thoughts from all of you. How would you like to see things develop over the next 5 years? What are your ambitions? And just short summary. Josh.
So with our expansion, we are going to rapidly run out of room to build our satellites. So I am working on a plea to help to ask Wales to help us build a facility so that we can manufacture our satellites to go into space. And if it's possible, I'd tell you what, some kind of a Wales visa would be amazing. Something that can help us bring in the international talent that we're bringing from as far as Brazil, to help us bring that talent in, and then help us set it up and help us develop that talent. We are looking to set up an apprenticeship program, hopefully next year, to help us crank those satellites out. Okay, good ambition. Steve.
Very similar to Josh. For me, it's about talent and skills. And I want the best access to those, because increasingly, if we can't, my primary objective is to get them here in Wales. If we can't, we'll go anywhere globally to do that, and we can base them anywhere globally. So we've got a great opportunity to ensure that we can attract that talent to Wales, but we've got to make sure we can do it quickly.
Tony, you've got a few seconds.
Our ambition is to get a network deployed over a portion of Wales and then the whole of Wales, to really connect all these communities. That's what our ambition over the next few years is, and we think that's hugely exciting, and we can think it's very transformative. And I've just been through the government plan today, ticking off all the things that we can help them achieve with it,
and potentially unlock the talent that we have in Wales, as well as the international talent.
That's it. Yeah, totally.
We're coming up to 15:30. I think it's been a fascinating session. Reminder that You can find out more by emailing me at inquiries.spacewhales.co.uk. You can go on our website. You'll have picked up the email addresses of the other panel members. Please contact any of us or the conference organizers. Some of you will be watching this in the future, time travel, because you'll be watching it on replay. But please do. We want to engage and have a dialogue with all of you, because this really is open innovation. And we are creating, I think, a better new world, potentially. So thank you very much. Thank you very much to our speakers, Tony, Steve, and Josh. And thank you all for watching and listening. Thank you.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.